we're ready to go as well.
Okay, I'll just start. All right, so I wanted to talk a little bit about competitive programming today. Does any of you know what competitive programming is? Have any of you heard about it before? No? Okay, so competitive programming is essentially that you get a bunch of tasks and then you have to write a program that solves these tasks as fast as possible. So when I was in high school, I competed a lot in competitive programming, and I wanted to just share a little bit about what it is today. And so my name is Simon. I live in Ottawa. I work at Shopify, and competitive programming is actually part of how I ended up working at Shopify. So I wanted to just show first an example of a task. So this is a task from the Canada's junior computing competition. So this is targeted at kids of essentially all ages. So these are the entry kinds of problems. So if you have does any of you have, I know Mac and Will have a little bit of exposure to programming before. Does anyone else here have experience?
Me.
Yeah, okay. Rowan?
Yes.
Anyone else?
So the kids had a 2-week program the last 2 weeks, and they were doing coding a little bit.
Okay, cool. So you have a little bit of an idea of like what a string is and things like that.
Yeah, it was in Java.
In Java, perfect. So then some of you might actually be able to solve this problem or have an idea of how you might be able to solve it. So this is actually from the Canadian computing competition in 2015. So the way that it works is that the Canadian competition is that you're handed a problem set of about 5 different problems, and then you have to solve them in 2 to 3 hours. It's a little bit like an exam. You're on your own. You just get a computer. You don't get a book. You don't get access to the internet. You just have to solve this with the programs that you write. So this is an example of a program like that. So you can imagine that. So essentially, what this is that you get a bunch of little text messages, and the text messages then contain these emojis. So they can contain happy emojis, they can contain sad emojis, and your task is to figure out the overall sentiment or the overall mood of the message. Is this a sad message or is it a happy message? And the way that the person who wrote this task decided that is that if there is more of the happy emojis in the text than there are sad emojis, then you print out happy. If there are more of the sad emojis than there are of the happy emojis, then you print out sad. If there's an equal amount of both of them, then you print out unsure because you can't figure out whether it's a sad or a happy message. So the way that could look is that the program that you could get, someone could type into your program would be, how are you? Happy emoji. Doing? Sad emoji. Today? Happy emoji. And then your program would have to see that, oh, there are 2 of the happy emojis and only 1 sad emoji. So the program would have to print out happy. Then here is one that looks a little bit harder. So this is a good example of what they often do in these competitions. The people who make the problems, they try to make something that might break your program. Your program up here might assume that an emoji always has a space before it and a space after it. But down here, there are no spaces. So you have to see them in the middle of a word. So here you can see there are 1, 2, 3 sad emojis and 1 happy emoji. And so that has to print out sad. And you might also here have some other problems in your program that might not cause it to work. So the first task of any competitive programming problem is that your program has to work. It has to print out the correct thing. The next thing after that is to try to make it as fast as possible, because the faster the program is that is correct, the more points you get. The more points you get, the higher the likelihood that you're going to win over the others who are competing against you. Does this make sense?
Yes.
Okay. Just put on your video and raise your hand or anything like that if you have questions. Okay. So there are some other examples as well of more challenging problems. So these are some of the ones that were really exciting to me when I started getting into it, was the prospect of learning to solve these kinds of problems. So one you might imagine is that when a delivery person has a truck they have to fit all of these packages inside of it. And finding out how to fit all of the packages inside of a truck can be really hard, right? If you have 2 pieces of furniture, that might take up all of the space of the truck. And you may have, when you've gone traveling, you may have found that sort of moving things around in a certain way allows you to fit more into your suitcase. Well, the delivery people who are delivering a lot more now than they used to have the same challenge. They have to put as many boxes as they can into their vehicles, and also make sure that they follow a very good route. So they go to one neighborhood and they fit as much into the truck as possible. So a problem that you might find at a competitive programming competition is to get a bunch of packages that your program gets, and it says they're this size, it's this big, it's this tall, this wide, and this length. And then your program has to say how many boxes can fit inside of a truck of a certain size. Another one that I encountered when I was in Australia competing was it was called the recognizing pictures problem. And so I don't know if any of you have seen on iPhone, I think Android can do this as well. If you search in the picture app for something like mom or yourself or something like that, it can recognize faces. If you search for pig or dog, it will also find you pictures of dogs. If you search for landscape, it will find that, mountains. So how can it do that? Well, so in this competition, they had a problem where you got a bunch of pictures. Some of them were of dogs, some of them were of landscape, some of them were drawings. And so you got maybe 10 pictures of each one of those things. Then your program had to be uploaded to a central server, and then they gave it pictures that it never had seen before. And all the program had to do was that it gets a picture, and then it had to print out cat if it was a cat, or dog if it was a dog, or landscape if it was a landscape. So that was a really, really interesting task. And this is the problem that you had to solve in just a few hours. Another one that I've seen come up in competition are different hacking challenges. So it can be that there's a secret message sent from one machine to another machine, from one person to another. And you know a couple of things about that message, and you can write a program to find out what that message was. Or you might get a list of passwords, and the passwords, and you might know that this is passwords, and a lot of these passwords have different kinds of dog breeds in them. And so when you know these things about them, then you can write a program that can try to hack these passwords and find out what they actually were in the first place. So it can also come down to that. So these are just some quick examples of other types of problems that can come up with these in these kinds of competitions. Does that make sense?
Yes.
Cool. So the competition that kids your age and older, anyone under the age of 18 can compete in, is called the International Olympiad in Informatics. So this is the most prestigious competition there is for people before university, and it may even just be the most well-known computing competition, period. So the only qualification, basically to get onto it, you have to qualify in the top 4 for your country. So you have to be among the top 4 in your age category, which is below 18 in this case, to get on the national team for your country. So in this case, all of you are, I think, Canadian citizens. So you would be competing to get on the Canadian national team in informatics. When I competed, I was living in Denmark, which is where I grew up. And we also have a national team. And there's actually 90 countries that have a national team in informatics. I met people from Kazakhstan, from Kuwait, from China, from the US, all over the world. I met people from Canada as well when I was competing. And one of my really good friends who actually ended up moving to Canada with me to work at Shopify, he was on the Dutch team. So I made a lot of friends through this, and there's lots of people competing from all kinds of countries. So as I mentioned earlier, everyone gets a computer and they get a bunch of tasks on paper. The tasks are written out the way that the one I presented earlier with the happy emojis and the sad emojis. And then you have a computer. You don't have books, you don't have internet, you don't have anything. It has to all be in your head, and you have to remember everything. You can't talk to anyone. You sit down for 5 hours, you have the 3 tasks, and all you can do is upload your programs to a central computer. You can also run them on your own computer, but you upload them to a central computer. Then you get back a number between 0 and 100. 100 is a perfect score. It means your program was the fastest that anyone knows that it could be. 0 means that you didn't solve anything. When you upload the program and you don't get a perfect score of 100, the server doesn't tell you what happened. It doesn't tell you why there is a problem. It doesn't even tell you, in the example of the packages before, it doesn't tell you which packages you didn't put into the truck in the best possible way. It doesn't tell you anything like that. So you have to figure out all of that on your own. In my case, I spent maybe half the time on paper just trying to solve these problems, and the other half on the computer. And because there are 3 tasks, you have to be very strategic. It may be that you can solve one task, but not the others. So you have to spend some time on each one of them, and maybe you get 50 points in one and 30 points in another, and maybe 100 points in a third. But if you spend all of your time on one problem, then you may not end up getting very many points. So that's what the international competition looks like. So I just wanted to show you a small video, so you just kind of get a sense of how big this event is. So this is from, I'm just going to mute this for myself here. There's no audio, but this is from Azerbaijan last year, where all these 90 countries sent people from the capital of Azerbaijan, Baku. And this is from the day 3. So this is the second competition day. And you can see here, they're all gathered in this big stadium. All of them have a laptop. They're looking at the problem sets. Some of them have their face buried in their arms as they're trying to solve these problems. And all of them are under 18. There are 11-year-olds who are competing in these competitions. And we'll talk about one of them later. And here you can see that they also go on excursions. So all the host countries, in this case, Azerbaijan, will take all of the contestants and show them their local culture, language, and what else might be happening in the area that they're in. So I also wanted to just show you, this is maybe reminiscent for some of you who've seen esports or something like that, where this is a competition for universities, where here you can see a scoreboard of how the different teams are doing. And in the university challenges, all of the teams are of 3 people. So their people actually work together. And during the competition, you can see here how many points they have. You can see all of them here. And you can follow them live, how they're doing on the different problems. And if you're really into it, you might actually follow this in real time and try to solve the problems. You can see that all the teams here have balloons. So every time a team solves a problem and gets a perfect score, they will take a needle and pop one of the balloons in the room to make it a little bit more interactive. Yeah, so you can see here teams from all over the world. Here's these teams of 3 people. One of them will be on a computer typing in the programs. The other 2 will typically be trying to solve the problem at that time. But this is more of a team one, whereas the one for pre-university students are for individuals only. There are also competitions outside of any schools, but you can compete in online. But these are the most well-known competitions, these 2. Okay. So this is an example of that event last year that was in Azerbaijan. You can see here, these are the people who won gold medals. So half of the contestants that attend to these competitions win a medal. And you can see here that there are a couple of countries that do really well. The US, Russia, Canada, China, Australia tend to do really well. And then there are countries like Korea, Kazakhstan, Japan, all of these have gold medals because they really take the training for these competitions seriously. You won't see anyone from Denmark in there. And if you look at Canada throughout the years, Canada is actually really good at this. They tend to win the gold medal in informatics every single year. And you can see they've won gold medals for just the past few years. 2013 and 2012, when I competed, they didn't win a gold medal. Do any of you know what cryptocurrencies are? No? Okay. But the guy who won a bronze medal in 2012 created one of the most popular cryptocurrencies when he graduated high school. So there are all kinds of interesting people in here who won these competitions and qualified for Canada. And then when you compare that to Denmark, we don't do as well as Canada. Denmark wins maybe 1, in rare cases 2 bronze medals a year. You can see my name down here. I didn't win anything. I just attended and tried to do my best. So I think there are two big reasons why Denmark doesn't do as well as Canada. So one is that Canada is just a bigger country. Denmark has 5.5 million people, and Canada has, I think, about 40 million. Is that right?
Yes.
So around 40 million people. So there's just a lot more Canadians. But I think the thing that makes the biggest difference is that the Canadian program is really good. Like that task I showed you before shows that they are getting kids interested when they're young. I only learned about these competitions when I was in my second year of high school. If I had started learning this when I was younger, when I was 10, 11, I think I could have done a lot better. So when I was your age. And some of the best people who are in this, they've competed with their country and then later get on the international team ever since they were 10, in some cases 9 years old, to train for this a few hours a week. That was Canada. So how do you get selected to represent your country? How do you get on the national team in this? So typically the way it works is just like if you're competing for track and field or any sport, is that first you have to become the best in your school, then the best in your city, then you compete regionally, that could be for Ontario, then you get to a national camp. I think in Canada, it's similar to Denmark where you compete regionally, and then if you're among the top 20, get the best points, then you get to a national camp with maybe around 20, maybe 30 kids. And there you compete for the top 4 spots. A lot of countries will then have regional competitions, so they will compete. For example, in Canada, I don't know if they do this, but they might have a friendly competition with the US because you're close. In Denmark, we compete with Germany and Sweden and go to Sweden and compete with them. And then if you do really well in those competitions as well, you might finally get on the international teams. So it's very similar to how you do it for sports, but instead it's just for computers. So I wanted to share a little bit of my own journey for getting on the Danish team. So first I wanted to ask, does any of you know anything about Denmark? Nothing.
One of my friends came from there.
Oh, really? Do you know where in Denmark?
No.
No? Did you know that Lego is from Denmark?
Really? I also.
Yeah.
Well, I know where he lives in Denmark, but I forget which place. Because I haven't seen him in 2 years.
I see. Do any of you know where Denmark is on a map? Which countries it's close to? Okay, I'll show you here. So Denmark is right over here. So it borders with Germany. It's between Norway and Sweden and Germany. Here's Denmark. And there's one thing that you all might not know, which is that Denmark and Canada are actually neighbors. So up here, Greenland is a part of Denmark. So many, many years ago, Greenland became a part of Denmark. Iceland used to be a part of Denmark. So all of Greenland is owned by Denmark. And up here, there's a border here in the Arctic Sea above the Baffin Bay. And that's where the Canadian-Danish border is. So we actually share a border. And right where that dot is, there's an island called Hans Island. And once in a while, a Danish expedition will make it up there and they'll put a Danish flag because it's right on the border between Canada and Denmark, goes through that island. So Denmark thinks it's a Danish island and Canada thinks it's a Canadian island. So when they put down this flag, a little bit later, Canada will come and they will raise the flag. Then Denmark will go and they will put up the flag again, and then Canada once again. And I don't know which flag is up there right now, but this has been a friendly border dispute for a long, long time. So for Denmark, the way that it works to qualify is that because it's a small country, we don't have regional or school competitions. So you, once a year, they hold an online competition, which is, I think, about 5 hours. And you compete online in the ways that I was mentioning before. You get a bunch of tasks, you upload your programs. The people who write the correctest programs that are the fastest get invited to this national camp. So they will invite about 12 kids to this camp. The first time I attended, I was 16 or 15. But there were some people there who were, I think the youngest was 12 of the people who competed there. And when I came there, I've been programming for a few years. I've been programming since I was 11, but these were different kinds of programs to write. Like suddenly it wasn't creating websites, it was solving these complex problems like the one I was mentioning with the bus and filling it up with packages. They were very different. And it was super fun to be exposed to this place where they were doing programming that I hadn't really seen before. It was a really, really fun weekend with all of these people. I had never met anyone in my town that was my age that was programming, but here I was suddenly with some of the best programmers in the entire country. And it was just one of the most interesting weekends, I think, of my life to be there. And at the end of that weekend, we had a 5-hour competition against everyone else who was there. And I was lucky enough to place in the top 4. And the top 4 contestants make it to a competition with some of our neighboring countries. So I showed you Denmark on a map earlier, and here's a little bit more zoomed in. And so we have a competition, a friendly competition with all of the Baltic countries. So the Baltic countries are the countries that are around the Baltic Sea. The Baltic Sea is the one here. And the Atlantic is out here on the left. So the Baltic Sea, there's lots of trades that go in here. So boats will come in here in Skagerrak, down Kattegat, and sail past Copenhagen, which is right here, which is the capital of Denmark. In the old days, Denmark used to be a really rich country because every ship that passed through this passage, we would charge them a really large fee for them to go to Sweden, to go to Finland, to go to Russia, Estonia, Latvia, and so on. So we still have close ties with all of these countries. Norway and Sweden have languages that are very, very similar to Danish. We can understand each other. Germany Germany is a country that we have long history with. And all of these countries meet up once a year to do a friendly competition. The first year I went was in 2012, and we went to Latvia right here and competed with all of these countries. And the second year I competed, we went to Rostock in the north of Germany here, competed with all of the same countries. Denmark and Sweden in particular have a really good relationship. So we've been to Stockholm once or twice to go and hang out with them and compete against them in a friendly way. And I still have some friends on the Swedish team today. So one of the things that they will do doing these competitions is that they will go on excursions. So when we were in Latvia, they took us on excursions around. And one thing that I found really funny was that in Latvia, they're very, very proud of their country. And they were really excited to show us Northern Europe's widest waterfall. And we had to take a 2.5-hour bus tour where in the bus tour, there was a guide, he was speaking Latvian, there was a translator later, and they were just talking about this waterfall for I don't know how long. So they were really talking up this waterfall. And so we go there, we go and hike for 30 minutes to finally get to this waterfall. And this is what it looked like. It was maybe half a meter tall. It was very wide, but extremely disappointing. And I don't know if any of you have been to Niagara Falls, but I think the Niagara Falls is probably both 100 times higher, maybe about as wide. But I thought this was a pretty funny excursion. So between the Danish competition and the regional competition against the Baltic countries, I had to spend a lot of time practicing at home. There wasn't a lot of schooling. A lot of the other countries, they will send them homework every week that they have to do, but there wasn't a lot of training for the Danish team, unfortunately. So I had to do a lot of this on my own, and balancing both attending high school, having a job, and doing this, and sports, and all of those things was really challenging. And that's part of, I think, the reason why I never got a medal in this, even though I competed for 2 years, other than not starting as early as I wanted to. And my journey, so IOI is the shorthand for the International Olympiad in Informatics. The first year that I went, it was in Northern Italy, up here. And the second year I went was in Australia. And one thing that I find really fascinating is, and this guy, he is the best competitive programmer out there. There is no one who is better than him. There's no one that's ever been better than him. He has competed he competed from 2006 until 2012. In the university matches that he went to university afterwards, he also destroyed every other team. He's hands down the best competitive programmer in the world. So if you look at this and really think about it, he started competing in 2006 and got a gold medal 5 years in a row and got a silver medal in 2006. In 2006, Gennady was 11 years old. So he got a silver medal when he was 11. I attended at 16 and didn't even get a bronze medal. So this kid has really been training a lot to attend in these competitions. I got to compete with him in 2012, and he is just extremely good. Yeah, you can see me here for comparison. Very young Simon. No medals won, but this is the score out of the maximum. So I got 33%. And if you get above 50%, then you get a bronze medal. There are also a lot of other competitions in a lot of other disciplines. So it's not just computer science and informatics if you're not interested in that. There's also competitions in math, in physics, chemistry, biology. They've even introduced history and linguistics and a lot of other disciplines. So if there are any of these fields that you're really interested in, there are all these opportunities to go and train on a regional level or see what the Canadian training is like. So if this is something that you're interested in, the number one thing is to just get better at programming and math. The informatics one is a combination of both math and programming. And the Canadian Computing Competition has a website where they have all of their past problems going back maybe 20 or 30 years, and they're really good to practice on. That's where I got the problem that I showed in the beginning with the emojis. So you can look at those. I don't know what the qualifications are for this year. It's probably past at this point, but you can definitely practice on some of these problems to try to get better. If it's something you're interested in, you can also talk with your parents about how you could get involved in this. And I would also be really happy to talk with you or your parents or both about how to pick up some of these problems and get into this.
What's the youngest you can be to do it?
I think you can compete. I think you can start as young as you can. Like the only qualification really is about whether you can submit the right solutions. If you can do that at 5, 11, or 17, it doesn't matter. What matters is just that you can't be in university yet, and that you submit the correct solution. So you can start right away.
Okay, I'm almost 10. I'm almost 10, so I feel like I got a good chance.
Yep, I think so too. If you start now, you'll be in really good shape. So I'll just show this website really quickly here. So this is the website here. So you can see here that I think they both host the one for informatics and for mathematics. In here you can see there's registration here. So you can register here. I don't know what the deadline is, but that's something that you can look at. You can see the results here from previous years, but I think the main thing is the sorry?
Did they do it at Waterloo?
Yeah, I think they do it at Waterloo, yeah. So I think if you, I think there's...
Okay, then my cousin goes there. So if I go, then I'll be able to see my cousin if he's there.
Yeah, absolutely. Yeah. And I think probably the first thing might be something online, but then they will likely take you to a camp, and then you can go to Waterloo, hang out with your cousin or whatever family you have there. Absolutely. And I think if you go in the problem set generator here, it will generate different problems. Let me just see if I can find the past contests. So in here, you can see that they have problem sets going back all the way to 2001 that you can practice on. But if you're serious about getting interested in this, I would love to help. So they have here these computing challenges. Some of them are also just math problems that don't involve a computer, but that are really good to practice on. And here you can see the actual computing competitions ones. Yeah. Okay. And then I think one thing that I just wanted to round off with is that what I learned from competitive programming that are still useful today. The first thing was just learning all these algorithms and data structures and thinking about problems this way. That was really good and something I use a lot in my work at Shopify. The other thing that I think is probably the most important is that I came to Canada when I was 18, right out of high school. I always thought that I was going to go to university, but I ended up with a job and doing exactly what I wanted right out of high school. I got really lucky. And so I never returned back for university. And I think part of it was that I was really fortunate to learn all of this stuff in high school. And I got some confidence that you can pick up these very complicated subjects that are at university level on your own. You don't need a teacher to learn these things. You can find the right books, email the right people, and stare at the problem for long enough, and then you will learn. So you don't have to learn these things there. And you can, if it doesn't, I've never had a computer course in my life, and it didn't matter. That was the subject I was most fascinated with. And sometimes I also became bored with some of the math problems we had, and learned that there were all these resources for way harder math problems and people who were really interested in these really hard math problems and computer problems around me. And then the other thing too was that I never got a medal. I learned so much being part of it. I learned so much practicing, but I was also doing a lot of other things. Some of the people who get medals, they've done it for much longer than I have. They've done it since they were 11 or 10. They've been working on these kinds of problems. And I couldn't catch up with that in just a year and a half that I had. But I still learned a lot. And the other thing too was that I also had a part-time programming job on the side. I still had to tend to university. I hang out with my friends and all of those things. So I felt it was okay to not be number one in that competition. Although I wish I would have done a little bit better. It was okay to play not to win because I still learned a lot. That's all I had for the presentation part here. Any questions?
Simon.
Yeah.
I think they'll be asking for ask Julia for your email because I think I might do it.
Absolutely. I'll put my personal email in the chat here. 1 second. I can't do that right now.
If you can send that to us afterwards, that would be great.
Here you go.
Yeah, so I got it, so I can pass it on to them for sure.
Okay, perfect. Do any of you have any other questions about these competitions or how you might get involved or?
I have a question.
Yeah.
How do you go about breaking down a problem when you get it when you start coding?
So the main thing is when you get one of these problems, such as the I probably won't use an example. I spend almost all of the time on paper. I don't go directly in and start writing the code. I never know the answer right away. So I usually start by drawing it. I start to draw what the computer might do, draw out the problem. If we're solving a problem of, what would be an example? What were some of the examples we had in here? The text message one. So in the text message example, I would write out some text messages, and then I would try to think of like, oh, what would be a hard text message? Well, what if it had to deal with an emoji that was a sad and a happy emoji merged into one? What would that look like? So I typically start thinking about what are the edge cases? What are the hardest things that this process, the judge could give this program? And then write those out. And then I would start to think about, okay, how would you solve that? What is the simplest possible solution? What is the solution that is easiest to code, simplest to understand? And then I would start there. And I wouldn't always implement that. If I wasn't sure if it was gonna work, I might code it up and then try to see if it would work. But I would always start with the simplest thing first. So the simplest solution is usually not very fast, so you usually don't get full score with it, but it means that you have a really good understanding of the problem. So when you have the simple solution, then I might start thinking about like, okay, what are the parts of this problem? What makes this slow? Why isn't this faster? And then I would start thinking about how I could make those individual parts faster, one by one. So that's typically how I've gone about these problems. And then also sometimes it takes days and hours to solve some of these problems. And in some cases, I may have to decide to switch over to another problem because I don't have time in the competition.
What languages do you code in?
So for the competitions, we were using C and C++. Day to day, I program mostly in Ruby, which is very, very similar to Python. Ruby and Python are very similar.
Okay.
How do you go about learning a new subject?
I usually, when I'm learning a new subject, so it could be a new algorithm or a new data structure that I know that I need, I will usually go on, just go on Google or go on Wikipedia, and then just start reading about it. I think oftentimes you might search for the perfect explanation for how does this thing work, but oftentimes I find it valuable to understand in very simple terms how does this work, and then again find my paper and then draw out what this might look like. So I use Google a lot. I use Wikipedia a lot, but then also actually sit down and try to really think about it. The nice thing about programming is that I can always just fire up my computer and then start programming it and see if it works. And that's a really good way to test your understanding. And so I try to do that as much as possible too.
Was Gmail made with Python?
Gmail?
Yeah.
I think it might be Python. Yeah, I think that's probably true.